Okay, so now let us see how the AI agent might go about building an explanation that shows that the object that had these properties in fact is an instance of this concept of a cup. What I'll do here is to first sketch out the explanation for you, and then I'll discuss how the AI agent actually goes about building the explanation. Let us first consider this part. This is an abstraction that we learn from the bowl. The object carries liquid because it is concave. Here is a similar abstraction learned from the briefcase. The object is liftable because it is light and it has a handle. Here is the abstraction that the AI agent learned from the glass. The glass enables drinking because it carries liquids and because it is liftable. So in this way, the abstraction learned from the glass gets connected to the abstractions learned from the bowl and the abstraction learned from the briefcase. Note that the effect here in the abstraction from the bowl has become the cause for the effect that was the abstraction from the glass. Similarly here, the effect that object is liftable was learned from the briefcase example. But in the context of the glass, this becomes the cause for object enables drinking. Now let's shift to the fourth example of a brick. From there, one learns that the object is stable because it has a bottom and the bottom is flat. Now we can connect this causal chain and this causal chain into a more complex causal explanation for why this object is a cup. Recall that we had said earlier in the definition of a cup that an object is a cup if it is stable and it enables drinking. Now we have shown that, in fact, this particular object is a cup because it is stable and it enables drinking. In practice, when an AI agent actually goes about building this explanation, it works backwards. From the definition of the cup, it knows that in order for an object to be a cup, the object must be stable and the object must enable drinking. So the AI agent sends its goal of proving that the object is stable into its memory. Memory returns the example of a brick because the brick is stable. But the brick said that the brick is stable because it has a bottom and the bottom is flat. So the AI agent abstracts this causal relationship from the brick example and applies it to the object here. Similarly for this part. Another aspect of the definition of the cup was that it enables drinking. So how can the AI agent prove that the object enables drinking, this object that it sees in the kitchen? The AI agent sends the goal of proving that the object enables drinking into its memory. Memory returns the example of a glass because the glass enables drinking. It abstracts from glass the fact that the object must carry a liquid and the object must be liftable in order to enable drinking. That sets up new explanatory subgoals. How can the AI agent now prove that the object can carry liquid? That goes back into the memory and the example of a bowl is found. And I think you can now see how the rest of the explanation process will work. Note this connects with a couple of lessons we have learned earlier. First, you can see problem reduction in application here. We wanted to prove that object is a cup. To do that, we reduce the problem into two smaller and simpler problems. Let's prove that object is stable and let's prove that object enables drinking, and so on and so forth. Second, this connects with the notion of planning. When we were discussing planning, we had open preconditions. Those were preconditions of a goal which we needed to satisfy. We used those open preconditions to select operators. A similar thing is happening here. When we want to prove that the object is a cup, then we have two open preconditions. Object is stable and object enables drinking. These preconditions then become levers for selecting explanatory proofs, explanatory fragments that can help fulfill those preconditions.
So the scenario of a robot proving that an object is a cup is a little bit of a longer term scenario. We're still a ways away from having robots that walk around our house and retrieve cups for us. To take an example perhaps from the near future, I can imagine one day having a word processor that has built into it some intelligence such that instead of choosing a file based strictly on its file name, I can say something like, "Get me that important document from last Tuesday." I myself might not remember the file name or where I saved it, but I remember that last Tuesday I was working on an important document. The intelligent search from the word processor would then iterate over the documents and say, can I both prove that the document is important and it is from last Tuesday? Now the word processor might not have a notion of importance built into it naturally, but it knows documents I've considered important in the past. And it might start to notice that documents that have my header on them and have my signature at the bottom are important. And from there, it can start to build a case for why that particular document is important. Coupled with just being able to read the timestamp and see if it's from last Tuesday, it should be able to retrieve from me documents that might be both important and from last Tuesday, without me ever really knowing what the document file name was or where I saved it.
this kind of explanation-based learning actually occurs in our everyday life. So you and I are constantly improvising. Papers are blowing off my desk. How can I stop them from blowing off? So I need something to stop them blowing away. What is available? What can act as a paperweight? A cup. Here is a cup. Let me put it on the papers. This is an example of improvisation where we use explanation-based learning to realize that anything that's heavy and has a flat bottom can act as a paperweight. Here is another example. I need to prop open a door. A door stopper is not available. What can I use? Perhaps an eraser or a chair. You and I do this kind of improvisation all the time, and often we are building these explanations that tell us that an eraser can be used as a door stopper.